Palo Alto Networks. I've been with the company about just over 2 years now, and during that time, I have seen some things. So I wanted to put together a couple of presentations for you. The first one is NAT, and you might be wondering, why are you putting together a presentation on NAT? NAT is simple. NAT is something that we all know how to do. The reason I put this together is because with the way Palo Alto handles network traffic, there's a couple of extra things that you need to consider when it comes to NAT. And also, since we have the parallel processing architecture, the way that security zones interact with the traffic is pretty important to understand. So first things first, basics of NAT, okay? What is the purpose of NAT? So NAT, you need to use NAT, network address translation, whenever you're going from private RFC 1918 space to the public IPv4 space, okay? You also need it when you're going from the public space to private RFC 1918 space, okay? Pretty basic stuff, right? It's fairly uncommon with IPv6, but when it comes to IPv6 to IPv4, there does need to be a translation there because obviously they're not natively the same. So what are the types of NAT in PAN-OS terminology? Okay, this is where we start getting into the weeds a little bit. Okay, so we have static NATs. We also have dynamic IP NATs, and we have dynamic IP and port NAT. Okay, all three of those are they have some significant differences. Okay, so how does NAT work? Put simply, NAT substitutes the source address, the destination address and port, or both of these options, with an address and port or address range that is configured by the firewall administrator. Okay, and it has to match a specific traffic pattern, and the substituted address depends on the type of NAT that you use. Okay, so a static NAT is when you want to replace the IP address in the source field or the destination field, or both. You can actually do both in the same rule, although it's fairly uncommon to do that. I have actually seen it. And it replaces either one of those with one IP address or one IP address and port combination. Okay, the intention of static NAT, this is the important part right here. It is one-to-one address translation. You only want to use statics when you have one IP address that you want to appear as another IP address. Okay. Next, we have dynamic IP NAT. Now, dynamic IP NAT is actually very similar to static NAT. Okay, but with dynamic IP NAT, you want to replace a range of addresses, and usually this is a CIDR notation subnet. Okay, so if I've got a /24 address and I want to translate it to a different /24, I would use this. So the intention here, or actually the most important concept when it comes to dynamic IP, is you want to make sure that the address ranges that you translate are equivalent. It has to be 100% equivalent. And the reason being is that this one right here, this dynamic IP NAT, it is doing one-to-one address translation on the range. So what happens if you have like a /24 that you try to translate to a /30? You're going to hit IP address exhaustion, okay? And then you'll have drop sessions.
But only if you're using both /24 addresses, just have two addresses in your /24, it should still be fine with /30 go down.
If there's only two addresses that are being used, you will be fine. But if there's ever more than two addresses in use in that /24, you will not be fine. You'll have a bad day. So the third type is dynamic IP and port. Okay, so dynamic IP and port NAT, it replaces a range of addresses with a single IP address, usually. It could be like a single IP address, or it could be just a couple of addresses, okay? Now, the way this is used is not only does it replace the address, it also binds each session from like the private to a port as well, okay? So if you're Cisco people, you probably understand the term PAT, or port address translation. Okay, that's pretty much our terminology for port address translation. And this one is the most common type of NAT that I typically see. And you guys probably are using this exact type of address translation at your home networks, okay? Because your ISP gives you one public IP, but you probably have many devices behind your home routers, okay? Pretty much the exact same thing. So when traffic matches a NAT policy that performs dynamic IP and port translation, okay, I just went over that. It binds it to a source port as well, so the virtual router knows where to return the traffic. So one thing that you do want to be careful of if you're doing dynamic IP and port translation is if you have an extremely large subnet behind a single IP address, because you can actually encounter port exhaustion, okay? since you have many-to-one translation, you can run out of ports. And I have actually seen that happen. So typically if you're doing, say you're going from like a say you have like a really big like /22 network with private RFC 1918 space, and every one of those addresses is full. Okay, everyone's in use and they're all sending traffic out to the internet. You can pretty easily exhaust, 65,000 ports. It's going to happen. So I just want to go over the anatomy of what a source NAT policy looks like in Palo Alto terminology. When I say source NAT, I'm specifically referring to what is being replaced here, okay? So you have your source zone, your source address, you have your destination zone, and your destination address. Okay, now here in the translation, this is what's being replaced. Okay, so you notice there's two arrows there. So the keyword with how NAT works in PAN-OS is policy, okay? And by that I mean when it comes to policies, every policy, not just NAT, security policies, SSL decrypt policies, authentication policies, if it falls under the policy tab in PAN-OS, it has a traffic match condition and an action that is performed. So right here, this column, see how there's like this like dark gold colored column header? That right there, the original packet, is your traffic match condition. And over here, you've got the action that is taken, okay? So for here, this is just a very simple NAT rule, dynamic IP and port. You've got the source zone is lab A trust, and the source address is any. Okay, so if I have, this is just for my home lab here, it's a very small /24 network. What that is saying is if you see any traffic coming from lab A trust, and it's going anywhere out on the internet, because the destination zone is the internet untrust, then just replace that source address with this right here. Okay, so this is the WAN interface IP of my, my firewall. But it's dynamic IP and port translation, so it's going to bind it to that WAN interface in addition to a port. So I just kind of go over the details there. Call it out. And yeah, it's pretty much everything I just said right there. So dynamic IP and port will bind that session to WAN interface, and usually it's a high port. The first 1,024 ports are typically reserved for well-known services, but high ports are usually what it gets down to. Now, this is the anatomy of a destination NAT policy. Okay, so destination NAT, again, it's referring to what gets translated. Okay, so notice here now, you notice it looks a little bit different. Okay, so the source zone is actually, I know it's kind of hard to see with the screen here, but the source zone is untrust internet, and the destination zone is also untrust internet. Okay, so what that means is every interface in PAN-OS, you have to bind it to a security zone. Okay, now the outside interface, the one that faces the internet, this one I consider untrusted, right? I don't trust the internet. Do you guys? No. All right, so it's untrust to untrust. And then you've got the destination address, so that's my WAN interface. But I also have a service port here, okay? So this is 443, okay, service HTTPS. Now, if you look at the action column here, you'll notice that it's translating it to an RFC 1918 address, okay? It's going to like 10.0.0.30, but it's port 443. So what exactly is this doing, okay? This means that traffic that's coming from the internet, destined for my IP address, like say I have a like a DNS entry for my my website that I host. The DNS entry maps to my public IP. What this will do is this will translate it to whatever that private IP address is, and it will forward it to that address internally on that port. Okay, so usually this is what you would set up for like a DMZ. Okay, I have a DMZ set up for my web server. My web server is listening on 443. It's basically port forwarding. Simple terminology is just port forwarding. But the zones is really what you have to pay attention to here, because when it comes to like what our competitors do, a lot of them don't really have the concept of security zones as a traffic match condition. It's usually just a label that you assign to an interface. So here we actually look at that as a traffic match condition. So you need to make sure that you understand that if it's coming from the internet and it's destined for you, it's also going to be untrust. It's usually the same zone and the source and the destination and the match conditions. The other thing that's important to note about NAT in Palo Alto, NAT will only affect how traffic is routed. It actually will not allow or deny traffic like a security policy will. It simply just translates traffic and throws it to a different IP. However, with destination NAT, this is really the meat and potatoes of what destination NAT can do. It has some interesting effects on security policy. Who here has taken the Firewall 101 course? A couple of hands here. If you have taken the Firewall 101 course, you have probably seen this diagram more times than you'd like to admit. Now, what this is doing is this is showing you the flow logic of how traffic is processed in PAN-OS. Okay, so what you'll notice here is that the initial packet processing phase, it looks at the source zone and the address, and it looks up user ID, then it looks up policy-based forwarding, and NAT policy is evaluated like fairly close to the end of that. Now, you'll notice that security policy is checked, but the NAT policy is not applied until after that security policy is checked. Okay, so that has some interesting effects on what you have to do with security policy for traffic that is affected by a destination NAT rule. The traffic match conditions must use the pre-NAT IP, meaning the public IP address, but it has to use the post-NAT zone. Okay? So if I have traffic, or if I have a security policy that is supposed to allow traffic to an internal system that I have, you have to use the address of that system before it gets NATed in the destination field of your address. But the zone has to be the internal zone. Okay, so if I have like a DMZ, I would put the public IP address of my web server there with the DMZ zone instead of untrust internet. It's very confusing at first, but after you do it a couple of times, you start to see how that works. And as long as you understand that flow logic diagram, you see exactly why you need to do that. And again, I just kind of go into detail here. Big red text. Make sure that if you remember one thing about this presentation, make sure that you remember pre-NAT IP, post-NAT zone. Okay. So bidirectional NAT also has an interesting property. Okay, so what do you guys notice about my NAT policy base here? Okay. See that policy right there is a static NAT, and bidirectional is enabled. What do you notice here? What's next to that arrow?
Hidden rule.
Exactly. It's not visible in the GUI, but if you look at it in the CLI, notice the index value here. You got 1, 2, and 3. If I do a show running NAT policy in the CLI, what do you got there? You got index 4. Okay, so whenever you do bidirectional, it creates a hidden NAT rule. But there's a very important property of this hidden NAT rule that you need to consider. If you have a very large environment that has a lot of east-west traffic, and you have like a zero trust architecture that has overlapping RFC 1918 space, this is very important. So essentially, all these arrows just call out what gets reversed in that return NAT rule. Okay, so you can see the source address. Okay, if the traffic is coming from here, it's my trust zone. Source address is an RFC 1918. It gets swapped with what is the in the translation field. Okay. Next, the destination. Okay, so if this is going from trust to the internet, anywhere on the internet, I don't really care. So the source could be any. To untrust internet. Now, what do you notice there? The zone is any. Okay, so that inverse NAT rule that automatically gets created by enabling that bidirectional flag, it replaces the source zone on that return NAT rule with any. So if you have a very complex multi-zone zero trust architecture internally, this can cause traffic flow problems. It could cause traffic to get routed to a zone that you didn't intend it to and possibly get blackholed. So very, very important that you understand what exactly that hidden NAT rule does, because it may make you not want to use bidirectional, but and you may want to actually just create like a specific NAT rule if you have an environment like that. Going back to the dynamic IP versus dynamic IP in port, I just want to share a story with you guys. Very important to understand the difference between those two, because I actually had this one bite me. Okay, so as a professional services consultant, the bulk of what I do is migration work. So I will go into an environment, a customer will have like an incumbent firewall vendor, and they upgrade to Palo Alto, but they need to convert that policy. So I had the migration tool that I used, and it converted the policy. And this particular customer had something like, I want to say like 220 some NAT rules. It was just a really big environment that had a lot of /24s. And in the Cisco firewall that this came from, they were all PAT rules. Well, what I didn't notice when it migrated everything over to a Palo Alto configuration, it automatically converted everything into a dynamic IP rule, okay, not dynamic IP and port. So what ended up happening is I had something like 200 plus /24 RFC 1918 networks that were getting translated to a single IP address, and that was it. So come cutover day, we started noticing all kinds of drop traffic. I mean, it was just bad. So we ended up having to roll back the cutover, and once I figured out what happened, then we went ahead and corrected it. The cutover went fine the next time we attempted it. So just make sure that you guys understand the difference between dynamic IP and port, and also make sure that you understand what the bidirectional flag does if you decide to use bidirectional for a static NAT rule. So I just go over the fields that get swapped there again. So just a quick little pop quiz here. So when do we use a source or destination translation? Okay, so here's a very simple network. I've got the internet. I've got a little PA220 here. I've got a WAN IP. Behind that, I've got a LAN. This is my inside trust interface here, and I have just a simple 192.168/24 network here, and I've also got a DMZ with a web server on it, and the DNS translates to stuff.com. Okay, so for this particular environment, what kind of NAT rule should I use?
Dynamic IP import.
Exactly. And it's going to be a source translation NAT rule.
Yep.
Because you're going to replace 192.168.0.0 with the WAN IP. And then you want to make sure it's dynamic IP import so the multiple devices that are behind here will have traffic be able to return. So what kind should go here? Based on what we all just heard. Yeah. It'll be a destination NAT rule, but it's going to be a static.
Yep.
Because it's one-to-one IP. So what I would do here, I would make a destination NAT rule. It would be source zone is untrust, destination zone is untrust, but the destination IP would be whatever that public is. And then the translation would just be to 10.20.20.15 on port 443. Any questions on what we've gone over today so far?
Is there a command that I can run to see what ports have been used for my dynamic NAT?
There is a command that'll show you how many ports are consumed. I don't think it'll show you exactly which ones are being used.
But it will show me how many are consumed so I can tell if I'm reaching ports.
Yes, I can't remember the exact command, but I can definitely look that up and send it to you if you
I know I
email.
used that one recently. I just can't remember what it is off the top of my head.
Yeah.
Is there a session monitor tab thing? I remember seeing something in the GUI. It's like session monitor.
There's a session browser.
Session browser.
Yeah, so session browser, that is actually only available from the local firewall context. So if you're a Panorama shop and you use Panorama to look at everything, you want to make sure that you change that context to the local firewall, then look at the session browser, and that'll show you all your active sessions.
So that will show PCs getting translated to a high number port on the outside to browse out to the internet?
I don't think it shows NAT. No, it doesn't really show NAT. It just shows you active sessions. So
Okay,
basically,
so
like it'll.
I think if you go into like the detail of an actual session, it'll show you like all the NAT translations and what IP. But there's no way you could like aggregate it and see.
Yeah, it's not one of the default fields in the table that shows you all of the sessions that are currently active. But he's right though. If you go into the session details, it will show you that NAT is being applied.
Although it does sound like something you probably get out of the command line.
You could even get it out of the traffic monitor. So like if you guys go to the monitor tab, I don't know if you knew this or not, but at the column header of every column of data in the traffic monitor, there's like a little drop down arrow. So if you just mouse over it, hit that drop down arrow, you can hide or make other columns visible. And there's a lot in NAT there. It'll show you whether or not NAT is being applied, and it'll also show you pre-NAT addresses versus post-NAT addresses. And actually port is one of the things there too. So you can actually look at the NAT port.
Give you what you want there.
Yeah. But typically, I mean, needing to know what the source port is or what port is being translated in like a dynamic IP port, that's usually kind of esoteric and rarely comes into to effect. It's more just to know whether you're hitting the exhaustion limit or not. That's really the most important thing. So, yes?
Have you had any situations where you see the message come up where it says such and such NAT rule shadows existing rule?
Yes.
Okay, so I have a fairly large NAT environment and I have that rule applied. And I know why. It's because my more specific rules are down a little bit lower and the more generic, say like the default internet rule is up top.
Yeah.
Is there a way to fix that aside from just rearranging those?
No, you have to rearrange the rules. Because if you have a more generic rule above the rules that are more specific, the more generic rule is going to get hit every time. So
Even in the case of like a default outbound internet dynamic IP port?
yes, because essentially when it comes to generic policy, so NAT policy, much like security policy, everything is a top-down match basis. So whatever the first policy that gets matched is, that's the rule that's going to be applied. So are you on PanOS 8.1 yet?
Yes.
So you know you have the hit counters and all that. Are you seeing the hit counters incrementing or decrementing, or not decrementing? Are you seeing them increment on the more specific NAT rules beneath your general?
They're absolutely working, and they've been working for a while. It's just that always annoys me to see the shadows.
Okay.
I figured it was just the order would be applied.
It is the order. So if you do have traffic that's hitting those more specific NAT rules, I mean, would it hurt anything if you put them above the generic rule?
Not at all. No.
Okay.
I just wanted to confirm that's what it was.
Yeah, I would just go that route then. Okay. I saw another hand up over here.
I was going to ask, does the Palo log the sort of port exhaustion? Is that pretty obvious when you hit port exhaustion?
When you start seeing sessions drop, you know, you're probably just going to go ahead and do an investigation anyway. But I would definitely make that one of the first things to check. If you see that there's like sessions getting dropped from a particular subnet, it's a real quick CLI command to see like what the port exhaustion is. It's actually going to be pretty hard to exhaust ports in a dynamic IP and port NAT policy unless you have the NAT oversubscription value set to like nothing, because essentially we support NAT oversubscription by default, and I think the default rate is like something like 8x. So if you take, you know, 60, it's going to be something like 64,000 ports. Multiply that by 8. Okay, like it's the only time I've seen port exhaustion happen is where oversubscription is just not a thing. They just haven't used it.
Also,
So-
the amount of users on, we're getting ready to deploy the O365, and I guess with the amount of apps, potentially each user could use 8 apps at the time, versus like between 6 and 8.
Right.
So if they're using all the apps at the same time, being a number of users, you could overexhaust it that way.
Possibly, yeah. So if you have a very large user environment, it could be a very real thing. So definitely, once I find that command, I can send it out to everybody, or I can even just add it to the slide afterwards, and then you're going to make all the slides available right then. Okay.
You can just post it to the user group email. You're on that, right?
I think so, yeah. I think so. I registered for Fuel like back before I was actually an employee of Palo, so I'll have to check that email to see if I get it.
So post it on there. That's the best place.
Okay.
So just to put a little context out there, at our company, we have 2 IPs for North America. We've never run into port exhaustion. We have 2 in Europe and 2 in Asia. We've never run into port exhaustion ever. Like hundreds of servers, thousands of users.
Yeah.
And we just do 2 public addresses. So
Yeah, so when you have the 2 public addresses like that, essentially it will fill up all the ports on the first one, and then it'll spill over to the second address and
Yeah.
start filling up those ports if that one gets exhausted.
I've
Okay,
actually
so we
kind
do
of
run
seen it
port exhaustion.
randomly
I see it
use
almost,
the 2 like.
yeah.
So it'll load balance them?
Yeah,
It's
so-
almost like it does. I was gonna ask.
I was
that.
actually, I can't remember the exact article, but I was reading where it fills up one so much and then it goes, it does load balance between the 2.
Yeah, because
I
like
can't remember the exact parameters of how Palo Alto does it when you have multiple addresses.
Yeah, I would be interested to see that too, just because
I'll see if I can find that. It's in my browser history because my boss was certain something we were facing was a port exhaustion thing, which I found absolutely no evidence, and then I found that article. So if I can pull it up out of my browsing history, I'll.
yeah, they were roll the dice almost. Like I'll do a curl against a URL I know that will return the IP, and I'll get one or the other throughout the day.
Okay.
So it's
So yeah, so there must be either like some kind of round robin or some kind of
Yeah,
load balancing
I think
algorithm.
it does do
Yeah.
a round robin almost.
That would make sense. So, any more questions regarding NAT before we move on to the next presentation? Going once, going twice.
Does anybody want to take a break beforehand, or you?
Actually, I wouldn't mind getting some water.
Okay. Yeah, so let's
All right.
let's take a quick break and.